Hello and welcome to um, the Math Portfolio Part 3. I will be doing Task 2, which is to create a video explaining how the graphical and algebraic representations are related in 3 cases of 3x3 systems, including one solution, infinite solutions, or no solutions. Okay, on to the first one. For one solution, we have negative 3x plus 2y minus 2z equals negative 10. 2x plus y plus z equals 4, and x minus 2y plus 3z equals 7. For this solution, we get 2 comma negative 1 comma 1. And we can we'd have to deduce either by substitution or elimination to find the answer for this. And then if we compare this to the graph, which is right here, we can see that all 3 planes clearly meet at one point, compacting into this singular area. You can see triangles being formed, or at least triangular prisms, I believe. Yeah, so the 3 planes connect in one point, and you can visually see how they connect and where. And then that brings us back, obviously, to those slides, back to the algebra, because we're seeing how these 3 planes can connect on the graph. So on to no solutions. Okay, so for x plus y plus z equals 4, x plus y plus z equals 8, 2x plus y plus 4z equals 5, there's no solution. And then we know this just algebraically by looking at these two, right? So they are on the same slope, but in different spots. So if we look at how this applies to a graph, this is the wrong one. Should be this one, yes. We can see how this red plane here, equation 3, hits both of them, right? Hits both of the planes, but the other 2 planes, equation 1 and equation 2, are parallel, which means they will never intercept, which means that all 3 planes will never meet up at one specific spot, so there can't be any solutions. Okay. And then back on to infinite solutions. So the question, 2x plus 2y plus 2z equals negative 2, 2x plus 3y plus 2z equals 4, and then x plus y plus z equals negative 1. And then there are infinitely many solutions. So when you're looking at infinitely many solutions, you can either have infinitely many solutions where all 3 match on a line, or where all 3 match on a plane. So for the first and third equations, all the solutions are the same on the plane. So all solutions would be the same. But for infinitely many solutions, we could have a third solution here that meets both of these identical equations on a line, which also extends infinitely, meaning there would be an infinite amount of solutions. Now, how does that look in a graph? It would look something like this, where you see we have this red, and then also, this gray, and then we have also the blue. So those 2 are on top of each other, whereas this red meets them both at this line, which extends forever if we zoom out, and creates an infinite amount of solutions. So basically, how we can see that the graphical and algebraic representations of these different equations can help us solve different solutions in different ways, but in many ways are connected. For example, we can visually see how the slope is the same for no solutions. We can visually see how all 3 planes for one solution meet at this one point. and we can visually see how two planes are literally on top of each other, represented by these equal equations. So I think that these numbers, you put them into a visual context of a graph, it helps us to further understand how these solutions get their answers and why. Thank you. Have a good day.